Greetings and welcome to the INCISOR Draw Poker demonstration. This complimentary project is here to help you dive into creating games and experiences using INCISOR's powerful development tools and APIs. The game made its debut at the 2025 ICE conference in Barcelona, where we showed it off running on both slot machines and mobile devices. In this demo, I'll play through a few hands of the game so you can get a feel for the rules and features. After that, we'll take a brief look at some of the key concepts behind building the game. And finally, we'll go over how you can get your hands on it and start experimenting yourself. Before we get started, if you haven't already, be sure to visit INCISORDev.com to download the latest version of INCISOR and explore the instructional tutorials. They'll guide you through the basics, help you get started, and further examine some of the more detailed topics we'll cover in this video. INCISOR Draw Poker was modeled after the traditional draw poker games many of us are familiar with. The rules involve placing a bet, receiving 5 cards, and deciding which to hold or discard. You aim to create the highest ranking poker hand possible, and winnings are paid out according to the pay table. I'll start by playing a few hands and walk you through some of the key concepts. To get going, click Deal, play 5 credits, or just hit the spacebar. You can adjust your bet size using the bet up or down buttons. There's an automatic hold feature, but you can always deselect any cards. When you're ready, press the draw button to replace any cards you didn't hold. Winning hands will be highlighted on the pay table and above the cards. If you want to turn off the game audio, just click the speaker button, and you can enable autoplay by hitting the play button. Let's have AutoRun play a few hands so we can get a look at some of the animations, particle systems, and sounds. If at any point you want to guarantee a winning hand in the next game, just click on the name of the hand you want from the pay table. The selected hand will be highlighted to confirm your choice, and you'll win that hand on your next deal. Now that we've seen the game, let's explore how it was built. We'll take a brief look at some of the core principles behind it. This tutorial won't go into great detail, but future tutorials will dive deeper into each of these topics. First up, let's explore the INCISOR user interface. As you can see, the INCISOR interface is fully customizable. It features a variety of panels, each offering different views, tools, and properties to suit your development needs. You can even design your own custom panels to provide the specific functionality you require throughout the development process. Panels can be opened by clicking here, and you can choose the type of panel you want by clicking here. You have the flexibility to place and move them wherever you like. Let's take a look at a few examples. The Tooltips panel offers detailed information when you hover over an item. You can see the tooltips in action as we navigate through different elements in the Object panel. For example, we currently have Card Location 0 selected, which is also visible in the Hierarchy panel. The Live View is an invaluable feature, allowing you to instantly preview changes without the need to publish the game, streamlining your workflow. In the Construct panel, you'll find a collection of objects that can be animated within the Timeline panel. To view an animation, simply select a state. By default, it's set to neutral state, but let's switch it to event. Now, you'll see the animation in the timeline. The Particle panel lets you create dynamic, real-time particle effects. For instance, if I select Coin Fountain, you can observe the effect change as I remove and then re-add Particle 1. These are just a few examples of the many panels available. Feel free to experiment with different panels and layouts to create a personalized INCISOR development environment that works best for you. Now, let's use the UI to explore the game's hierarchy. At the root level, we have the main scene, which contains a single orthographic camera. The game construct serves as the master construct, housing other constructs and graphical elements. Notice that each card is treated as a separate construct, while the pay table is added directly to the game construct. We can also dive deeper into other INCISOR components used in the creation of this game to understand how everything fits together. We'll start by focusing on the INCISOR Graphic Expander. Graphic expanders are a great tool for creating dynamically sized graphics without stretched edges, and they do so with significantly reduced download size and load times. They also lower the graphics card memory footprint and boost overall performance. This game makes extensive use of graphic expanders. Let's take a look at one of the background boxes on the pay table. I'll open the Object Inspector and adjust the properties of the background's graphic expander so you can see the asset change in real time. If we set all properties back to 0, you'll see the original image. As you can see, Using Graphic Expander results in a pretty significant reduction in size. Next, let's check out some of the game logo animations. The animations are created using Incisor's timeline editor, along with the swoop and add motion APIs. All the particle effects are generated in real time, which means there are no sprite animations or pre-recorded videos used in this game. I'll open the construct and timeline editor, along with the live view, to give you a closer look. In the construct window, I'll select the game logo. By default, the neutral state won't automatically load in the timeline, so we'll change it to the idle state. Scrubbing through the timeline lets you view the full animation, and hitting play will loop the animation so you can see it in action. If you switch to curve mode, you'll also see a graph of the values controlling the animation. The pay table is created using Incisor text boxes, which makes it data-driven and allows for real-time swapping. This approach also helps reduce both download size and memory footprint. I've selected the Royal Flush text box, and its data will appear in the object window. You can adjust properties like position, scale, and rotation along with other data. These changes are temporary and can be cleared by refreshing the screen. There's still much more to explore within the Incisor UI and Inspector. You can even add your own custom elements using Incisor extensions, which we'll cover in another video. Alright, let's jump into some code. I'll be using VS Code. It's my preferred editor, but it's definitely not a requirement. We'll start with a high-level overview of the key elements of the code, beginning with the entry point for every Incisor application, the init function in project-main.js. Draw Poker is written in JavaScript, but Incisor also supports TypeScript, so if you're interested, check out the tutorial videos for a walkthrough on setting up an Incisor TypeScript project. Following best practices, the game's logic is separated from the interface. It's built using object-oriented principles, with all the code organized into different class files and packaged logically. Starting with the very first line of code, we set the main camera's adaptive camera to maximize safe zone. This ensures the game resizes to fit the browser window and uses the Core Canvas Resolution X and Core Canvas Resolution Y settings. You can adjust these values by going to Project Settings. I'll go ahead and remove this line to show you what happens when it's not there. You'll also notice the frequent use of NC dot throughout the code. NC stands for Incisor, and it's the key to accessing all of Incisor's internal functions. You'll also see PR used often. This provides a way to access globally scoped variables that were initialized inside the project main init function. The next line retrieves an instance of the game construct. This is the main construct for the entire game, and it includes other nested constructs within it. We use construct getter as a helper to simplify the function call for descendants by name. As for the game's audio, it's synchronized by starting all of the looping sounds at the same time, and then the volumes are gradually ramped up and down. The sounds index helps with keeping everything in sync. As previously stated, the game's logic is kept separate from the user interface, which is crucial for a production game. This separation allows for the use of a mock client or a logic simulation module to test the game, or to let a client engineer work independently from the backend developer. The two parts communicate by sending custom Incisor app events. When you call the poker logic run functions, it kicks off the entire game cycle. The game logic handles just two events. The init game event is used only at startup to provide the client with all the initial values for the meters. The game outcome event is sent every time the deal or draw button is pressed. It sends all the necessary data for that part of the game, like the evaluation results, the cards to be displayed, and the bank. These events are built into the game logic, and they can be sent out as needed. To define custom events, we use nc.defineAppEvent initGame. The game logic also listens for 3 client events by using a callback. This is done by calling nc.appEvents, followed by the name of the event you want to register or listen to. The client triggers the request deal or request draw events. It's important to note that the game logic always maintains control, as the client can't be trusted. So when the request deal event is triggered, the logic's process deal function is called. As we discussed earlier, you can manipulate the cards for the upcoming games, By pressing the winning hand, the Request Gaff event is triggered and the pay category for the chosen hand is passed. For more info on app events, check out the Incisor tutorials page. Now let's look at motion. Add motion creates continuous movement, but you can adjust or stop it by modifying its influence. This function returns a motion object. To make it more dynamic, we add a new variable called scale motion to the hand name text and assign it the motion object. Now that we have access to the motion instance, we can tweak its influence to create smooth fade in and fade out transitions. In this case, the value is set to 1 for full motion, and it'll be set to 0 when we want to stop the motion. Lastly, let's take a look at swooping. Similar to add motion, swooping interpolates a numeric property over time. The key difference is that, unlike add motion, swooping is finite. It doesn't run continuously. In this example, we're swooping the alpha value of the text box, gradually fading it down to 0. This creates a much smoother, more visually pleasing effect than instantly turning the visibility on and off. And that's a wrap. You've just seen a complete game built with Incisor, showcasing many of its capabilities. This game can serve as a great starting point to boost your knowledge and help you start building your own Incisor applications. You can download the project at www.incisorddev.com/downloads. Thank you for watching. Enjoy creating with Incisor.